Welcome to the first introductory lecture of the course Electrical Insulation in Power Apparatus and Systems. Now first let us understand what we mean by electrical insulation. As electrical engineers, we are normally concerned with those parts of our circuit or those part of the apparatus which is concerned with transferring electrical energy or electrical power from one point to another. And so we most often are concerned with building better circuits. However, what we tend to forget is that for power to be transferred from one point to another through electrical circuits, we need proper insulation. And what does the insulation do? The insulation prevents the currents from flowing in unwanted directions, unwanted regions, which means that we constrain the electric power to be confined to the circuits and we prevent power loss and other problems that might happen if we do not provide adequate insulation. Now, in this course, we are not only just going to talk about electrical insulation, we are also going to talk about electrical insulation systems. Now, how are electrical insulation systems different from electrical insulation? Now, an electrical insulation system doesn't only concern itself with just one insulating material, because most often when we provide insulation to a system or an apparatus, we are not going to just provide one material, but we are going to provide a combination of materials which taken together serve as the insulation system in the sense that it provides electrical insulation, but not only that, it also has non-electrical functions. For example, let's take the case of a transformer. In a transformer, you use transformer oil. The primary function of the transformer oil is, of course, to insulate the conducting coils from the tank of the insulation, from the body of the transformer tank. But that apart, the reason that we particularly choose transformer oil instead of, let us say, choosing some other solid material is because in this situation, we also want the oil to perform the function of cooling of the turns or the coils. So basically, an electrical insulation system is a unique combination of materials. These materials taken together provide the insulation, have dielectric properties, and in addition to that, they may also have some non-electrical properties, non-electrical functions, and they must be electrically and chemically compatible to each other. Not only at room temperatures, but even at elevated temperatures, they should be electrically and chemically compatible to each other. And this whole system of materials taken together comprise of the electrical insulation system. And you have different combinations or different kinds of electrical insulation system depending upon your applications, for example, for motors, for transformers, for relays, or for solenoids. Now, insulation engineering is nothing new. We have been providing insulation to apparatus ever since there have been power apparatus, ever since we have had circuits, we have had transformers. But why do we have a renewed interest in insulation engineering in the current times? There are certain reasons for that. There are certain technologies that are available to us currently which were not available to us in earlier times, let's say 20, 30 years ago. And what are these? We are now looking at a lot of new materials which are coming up, and we find that we might be able to use these materials with greater advantage instead of the conventional materials that we are currently using. Moreover, we have now a large number of advanced measuring and analytical technologies as well as high-speed data processing, which means that processes, high-speed processes or very complicated processes which we were not in a position to study earlier, we are now in a position to study. For example, how exactly does lightning progress? How exactly does a discharge happen inside the volume of an insulating material? These are things that we did not have a very good idea because we could not experimentally trace them. We can do that. We can perform experiments to understand them better, and we can also use computational techniques to understand and simulate what might be happening, which leads to the good performance or the bad performance of insulation system. Another thing that we need to remember is that currently we are going from higher and higher voltages. We have gone from 400 kV transmission lines, transmission systems to 800 kV transmission lines. We are now looking at 1200 kV transmission lines, which means that every power apparatus, every apparatus that we're going to use in the transmission system or the subsystem have to be designed to be able to withstand the high voltages. The insulation will be taxed to the utmost in the sense that we cannot keep on providing more and more insulation, because you have to remember insulation is the non-productive part. If you provide more insulation so that you can withstand higher voltages, what it would mean is that you would have very bulky equipment, and it will also become uneconomical, because you're going to spend a lot of money on the insulation. So we would like to have more compact insulation, especially for special applications, like if you have to take design power apparatus for space environments. You would like to have compact and economical equipment. And at the same time, power equipment are very expensive, and they're also very huge. So we expect this power equipment to be in operation for a very long period of time, at least 20-30 years, because we cannot afford to have frequent outages or frequent maintenance outages either. And therefore, we have to look at a situation where we use very little insulation, we do not increase the cost of the insulation. At the same time, the insulation must have a bigger life. So we are looking at extended life of equipment. So these are the concerns that we have in designing electrical insulation systems. And as we know, to design electrical insulation systems, what we need are dielectrics. So in the next module, let us look at what are the different kinds of dielectrics and what should be our concern when we choose dielectrics for use in insulation.